Hi there, welcome to another video from Hegarty Maths. It's Mr. Hegarty here, and in this video we're going to be substituting into important formulae. Now what I thought would be really cool is, given that we've just done substitution, it would be really nice if we looked at some of the really important formulae that we're going to be seeing, not all of them because the video is not long enough to cover all of them, but just some of them, and practice some substitution into those formulae. Now here's a really big formula, the quadratic formula, which we've met in the quadratic section. Just pause the video, link into previous learning, and double check you can find the two values for x here if a is 2, b is 5 and c is negative 4. Okay, hopefully you did it like this. If not, go back to your building blocks on quadratics. The first thing I always want you to work out is this b squared subtract 4ac, which is called the discriminant, and I got it was equal to 57. And therefore I could just substitute in nice and easily then, and I got negative 5 plus root 57 all divided by 4, and negative 5 subtract root 57 all divided by 4. And that's a formula we've got to be super good at substituting into, and my little trick for that was to always work out the discriminant first. Okay, let's try some other formulae now, and we'll go through together. If you feel like you can do any of these, pause the video, otherwise I'll go through in a few seconds. So here's the area of a trapezium. We're given a is 3, b is 5 and h is 2.5. So let's work out the area. I'm not going to explain where the formula comes from. That will come within the geometry section. I'm just going to substitute into it. Keep that half there. A is equal to 3 and we're adding 5 and we're multiplying all that by h, which is 2.5. And we make sure we put that 2.5 in brackets to remind us it's multiplying. Okay, now what we're going to do, keep that half there. 3 add 5 is equal to 8, so that's a half multiplied by 8 multiplied by 2.5. Well, a half multiplied by 8 is 4, so this is like 4 multiplied by 2.5, and 4 multiplied by 2.5 is equal to 10. And there we go, we've successfully substituted into the area of a trapezium formula. Right, next one. The displacement or distance formula. Pause the video and see if you can substitute u, t and a in there to find s. Well, s is going to be given by u, which is 3, multiplied by t, which is 12. And what we do to that is we add a half, and we multiply this by a, which is 4, and t squared, which is 12 squared. So let's see if we can work that out. 3 multiplied by 12 is equal to 36. Let's do the half multiplied by the 4, which is 2. So that's add 2 multiplied by 12 squared, which is 144. That's 36. Now 2 times 144 is going to equal 288. And then if we add these two things together here, if we add on 6 we get 294, and then add on the 30 we're going to get 324, and we are done. Next one, pause the video, have a go. Now this is a rearrangement of the Pythagoras formula. We're trying to work out b if we're given a is 13 and c is equal to 5. So b is going to be the square root of 13 squared take away 5 squared. Okay, so that's the square root of, now 13 squared, you should know that, 13 squared is 169, take away 5 squared, which is equal to 25. If I do 169 take away 25, I get the square root of 144, and the square root of 144 is 12. So b is 12, and we're done. Next one, see if you can substitute these pairs of coordinates into the distance between 2 points formula. So here the distance d is given by the square root of the difference in the x value squared, so x2 subtract x1, that's going to be 3 subtract negative 2, so 3 subtract negative 2 all squared, add y2 subtract y1, so 7 subtract 1 all squared. Okay, so let's see if we can work that out. What that's going to be, 3 subtract negative 2 is basically 5 squared, 7 subtract 1 is 6 squared. So 5 squared is 25, so this is the square root of 25 and 36, and that's going to equal, adding those together, you're going to get the square root of 61, like that. And 61 is a prime number, so that's all we can do with it. I could decimalize it, but there's no need to at that point. So we're done. Right, next one. Use the area of a sector formula with theta being 90 and r being 4. Evaluate A, leaving your answer in terms of pi. So A is going to equal, well, 90 divided by 360 multiplied by pi and r squared, which will be multiplied by 4 squared. Now 90 divided by 360, okay, 90 and 360 have a highest common factor of 90. You can divide the top and the bottom by 90, and that simplifies to a quarter. And you should know that 90 degrees out of 360 is a quarter anyway. So we'd be better off writing that as a quarter multiplied by pi multiplied by 4 squared, which is equal to 16. Now we know multiplication is associative and commutative. We can multiply in any order. So why not multiply the quarter by the 16? That's the same as 16 divided by 4, which is 4. And we're told to leave our answer in terms of pi. So leave that pi there. A quarter times 16 is 4, and leave your answer as 4 pi. And A is 4 pi, and we're done. And the last one for us now, pause the video and see if you can use the circumference of a circle formula. Now this one was a little trickier. It said given that r is equal to 3, evaluate D and C, leave your answer in terms of pi where appropriate. There were two formulae. To work, you had to use this formula to work out D, and then having worked out D, you had to use that D to work out the circumference in this formula. So let's do the two steps. D was equal to 2 multiplied by r, and 2 multiplied by r is 2 multiplied by 3, so D is equal to 6. That was step 1. Now we know the circumference of a circle, or this formula here, is C is equal to pi times D. So when r is 3, D is 6 we found, so we're going to substitute D as 6 in here. So C is pi multiplied by 6, which a mathematician just writes, if leaving in terms of pi, they'd write the number first, 6 pi. And that's it. And we've done some really cool substitution into some really important formulae in maths, and I hope you found that useful. Thanks for watching.